Hello, this is Trevor, and we are back with another Web Security Academy SQL injection lab. This time, it's a SQL injection with filter bypass via XML encoding in its stock check feature. The results from the query return to the application so you can use a union attack to retrieve data from other tables. So we need to find the users table, usernames, passwords of registered users, SQL injection text, admin users' credentials, then log into the admin account. All right, let's check this out. Remember, it's a filter bypass via XML. Please remember to like and subscribe. Let me know in the comments how I'm doing. So remember, it was the check stock feature. Let's make sure we are proxying this. Let me refresh the page and then hit the check stock. We do have a response. Let's go to proxy, history, and this one. So I'm going to send this to repeater. All right, so we have a SQL injection that we're going to be able to union select. What's interesting? So we have two possible injection points. Number one. Number two is, notice how they're numbers. And so this is important because, let's see, docker ps-a. Let's go to Postgres. So docker exec Postgres. If I do like select, let's do select actor ID from actor where, and I'll just do actor ID again equals 1. This is what I think the query looks like. Obviously, some of the names, both the table name and the column names are changed. But I guess what I want to point out is that I don't have any quotes here, and it's returning a number. And I think that is what we see here. Let me send this. No quotes here, and it's returning a number. So I don't think we will want to do a single quote. We can try it though. Just my instinct tells me it's a number. So why have a single quote? And we get attack detected. And this is that filter bypass stuff that we're going to have to work through, because the WAF is, detecting our single quote as malicious. So let's go back here real quick and decide what we want to do, and then how we're going to do it next. So remember, the one is where our injection point is. What if we do space union select null? Maybe comment out the rest and space. Something like that. We still get, we get 2 rows, even though it's only showing 1. The second one is the null. This is what I think we need to do. So this will be our payload here. We need to do 2 things. Figure out which of those is vulnerable. Maybe they both are. I don't know. And then figure out how we can bypass the WAF. Let's just start here. And I want a space just in case it's MySQL. That space is important. We do have the attack detected. That's expected because we are definitely SQL injecting here. One thing to notice is that this is all in XML, which means that as it goes through the Web Application Firewall, it will be URL encoded, and then as the application gets it, it will need to read in the XML before it sends it on to SQL. With that in mind, we should be able to take advantage of that process, that conversion from or interpretation of XML before sending it on to SQL. How we can do that is by encoding some of these to try to bypass the WAF. So the WAF sees it, no, this is not, malicious. But then when it gets decoded from XML and before it gets sent to the SQL injection, it becomes, what we want our string to be. So I believe, let's look up, let's go here, Chrome, and let's do XML encoding. I want character, XML, not HTML character. We don't want entities necessarily. This is what I'm looking for. So we can do this format or this format. And the difference is this is decimal and this is hex. And I think we can also do these entity references, but we'll check that. All right, let's use hex because I know hex a little bit better. And we'll start here. So a space, if you remember in URL, it's %20, and that's the same hex number. So ampersand pound x, right? 20 semicolon. Let's check this out. Ampersand pound x 20 semicolon. Good. Let's do the U, and I don't remember what that is. Let's go to decoder, type in U, and then we'll encode it as hex. Nope. As URL 55. So if we go back to a repeater, change this one to ampersand pound x 55 semicolon. Now the NION, we can encode all the characters, but let's try it without that for now. Because if it's like regex based, it's looking for specific characters or words, and NION is not a word that it needs to be concerned about. So let me copy this space, put that here, and then the S decoder, I'll do a capital S, encode as URL. We get 53, whoops, Peter. So ampersand pound X 53 semicolon. Elect again is not one that we need to be concerned about. Copy this. See, like here, we'll try it after. I think I can use the and NBSP instead of this, but I don't want to make that mistake. I don't think null will do it if we have to. Let's try the dash %2D. I should have known that one. So ampersand pound x2, I'll do a capital, why not? Semicolon, and then we're going to do that again. And then the space at the end, just in case it is MySQL. All right, so that should union select null. So let's see if that gets anything back. Hey, look at that. Awesome. And just for grins, I want to change this. Remember I said we could use named entities, so like ampersand NBSP semicolon. This would be an XML HTML entity. I just want to try this. Nope. That did not work. Maybe non-breaking, maybe that's different than and pound X. What was it? 20. All right. So next we need to see, because we want to get information back, we need to see if we can do get text. And right now we're just getting null. And the category or the original column is an integer. If we can only get integers back, I may be barking up the wrong tree here. And I don't know what I would do. So let's do some like this. I'm assuming we have to URL or XML encode those characters. So let me figure out what those are. The single quote, 27. I do that every time, don't I? So ampersand pound X27 semicolon. And I'm going to copy this and replace this. And our goal here is to get A back. If we get A back, yes. Sweet. So we know we can pull data from the database. And I just want to try this one more time. A pause. That's the single quote HTML entity. It should be XML also. Hey, that did work. So we can use named entities, but not the NBSP. I don't know why. Anyway, let me put this back. Ampersand pound X27. All right. And we know that this is vulnerable. Sweet. Just out of curiosity's sake, I want to see if this is vulnerable. It is. We only get one. So we can use either field. I don't know which one we want to use, but we can use either. All right, let's start creating our script. Our script is going to need to encode do all this encoding for us. We're going to need to get tables to find out the name of the user tables, I'm assuming, because contains a user's table, and it doesn't say table name or column names. So I'm assuming this is another one where we have to figure that out. All right. Well, what is this called? We're going to name it SQL injection with filter bypass via XML encoding. A nice short name. So, crap, I already forgot it. My joke was SQL injection with filter bypass via XML encoding. Filter bypass SQL injection filter bypass SQL injection with filter bypass via XML encoding. I don't know if that's right, but that's what we're going to name it. Let's grab our template. Paste that here. Let's create our shop object. Shop equals shop args dot URL args dot no proxy. we do need to log in. So I'm going to do sesh equals requests.session and add that here. Okay, so let's start out with our payload, the format for our payload. So maybe we can put that def format payload, and we'll take in the exploit or the query we're going to run, and then we're going to return triple quotes, and then here we are going to put this. I want to remember the content type, application XML. I probably need to set that. We can test it, see if that's important, but for now, let's pretend it is. And right here, I'm gonna do query union select. Oh, let's do, yeah. Let's delete all this for now. We can copy it back when we need to. Return, so we need F. But let's do one other thing. Formatted query equals. Let's format query. So let me change this to formatted query. And then let's create that other function, def format query. So this function's whole job is to take our normal string and selectively or all at once convert it to bypass the WAF. Right? So it needs to XML encode characters. I don't know if Python has a library for this, but we can do, let's do IPython. Whoops. I wanted IPython. What's the ones? We know a space is a space should equal. Here's one of my thoughts. We could create a dictionary, like a lookup table, lookup like this, and have the characters be the keys, and what we should ampersand pound x 20 like this, right? And let's do one more. Let's do a single quote, I guess, which is one I don't remember. Single quote is going to be around the A. It's this one. That'll be good enough for our, we need lookup equals space that. Whoops. Okay, now if we, for x in, let's do a phrase, select space A, for instance, say that this was our query, then we could do for x, so for each character, we need to, if x in, if x in, can't we do this lookup? X equals lookup x. I think we can do that. and then print. We would want to combine these back into a string, but yeah, that would work. So let's do this. Answer equals, or formatted equals this. And then we run our thing. Instead of printing, we do formatted dot append x. And then this dot join formatted. And see, there's our string with all the characters that we think are that need to be encoded are encoded using the lookup table. So select space, that's the single quote, a single quote. We could do it that way. We could also just encode every single character, so we could go through each character, get the decimal equivalent, or maybe even the straight hex equivalent of that character in, an ASCII table, and then add this to the prepend it with that, and append it with the semicolon. Those are our two options. I'm leaning towards the lookup table. Yeah, let's do that. So I'm going to make this a global variable, look up. And again, I need the equal. I'm going to steal these. I don't know which one's right. Okay, so we got the space, we got the single quote. I know we need the U. We had to include that. We had to include the S in the select. What else did we have to encode? So space, that's the U, space, that's the S, space, single quote, oh, the dashes. Or the hyphen. All right, that should be, let's start with that. And if we run into any other characters, we can start encoding those. But that is a good start. The U is going to be this. The S is going to be this. The dash is this. And look over those, they all look right. So all have an ampersand, all have a pound, all have an X, and all have a semicolon. We'll start with that. And then if we need to, we'll add more. So formatted query equals, boom, boom, just like we did in IPython. We'll do for char in, we'll name this query again, in query. And then we'll do if char in lookup formatted, no, we want char equals lookup char. And then right here, we append it. So formatted query dot append the char. And then finally, we return it here. So return no spaces, dot join, formatted query. Perfect. Query there. And then we insert it here. Looks good. I like all of that. So now that we have those, let's start off with just making sure we can get AAAA or ABCD. So shop, we need to figure out the URL product/stock. And it's a post. And remember, I talked about the content type. Let's check that real quick. Make sure this is still live. If I do HTML, it still works. Just see if it's actually checking it. It is not checking the content type. Whew, good. It's a load off, but we don't have to worry about that. And anything else look interesting? Is the session important? Let's try sending it without that. It's fine. We don't need that. Looks good. And the response is going to be text plain. That's going to be interesting doing our regex or trying to get the result. Can we, what if we don't provide a valid store? So I don't know if 0 is going to work, but the other option would be something really high. Perfect. Now we only get our response back, so it'll be easy to regex. Sweet. All right, so post to product/stock. Let's go here. URL equals shop.base URL plus this. We need to remove this. And requests.post URL. The body, if we do data, I think data has to be a dictionary. I don't know how we would post requests, post. I don't want to do, so it has XML. I don't think I want to do, if it has a library for XML. Data equals XML. Ah, okay. We can just do data. Ooh, good. I didn't want to have requests format our XML, right? I wanted to do it myself. Data equals XML. We're not going to change the headers because we tested that. It doesn't matter. Shop if shop.r.no proxy. We'll do this. We're going to save the response. Else, we'll do the same, but through burp proxies equals proxies at utils. And remember, we need verify equals false. Right now I have XML here, which is wrong. We haven't defined our payload. Payload equals format payload. And our first one is going to be, oh, remember we decided we were going to use 0, R0. And I should put a space here. And I'll just do that manually. And pound x20, just so we don't have to remember to start with that, equals union select single quote, A, B, C, C, D. That is what we want. Let's make this line shorter. So I'm going to take off the F and the triple quotes. Let's do this. I used triple quotes at first because I thought when I was copying it, it was going to be multi-line, but it ended up not being. Let's change this to single quote because there are double quotes in the string. And then let's end it here, I guess. Nah, let's end it right before this. And remember, I need the parenthesis here. Let me join that. Let me write it so it formats it a little better. And then I'll do the F string. Oh, crap. I want single. Maybe it changed it for me. It probably changed it for me. Because it prefers single quotes. And I need to do an F string here. Do I need F in both? No. No effing way. Okay, that looks good. Payload. We've got that set now. And so we need to use that here. Payload. And here. And then to test it out, let's do print resp.text. Control D, yes. And then Python SQL injection with here, make sure our lab is still alive. It is. Copy this. Paste it, hit enter. A, B, C, D. Woo! No logs. So let's see. Log.info, sending union, sending SQLi payload. Let's have that. No. I don't want to do, well, we can. It's going to look bad. Payload, but at least we'll be able to check it. All right. So we need to figure out the tables. Let's do table name, select table name from information schema.tables. This should work for everything except for Oracle, if I remember right. Do we have our, nope, SQLi cheat sheet here. Database information schema tables. And we're going to grab the table name. So that should work for all of them except for, like I said, Oracle. Let's try that. Ooh, and it's Postgres. Sweet. With Postgres, we can do where schema. Dang it. Let's, I don't remember, but it's okay. I don't have to. If I go here, and we do have select asterisk from information schema dot tables, and I'm going to limit 10 just so we don't get bombarded. Table schema, that's what I wanted. Where table schema equals public. Boom. That should give us a much better response. Except for we're going to change this to table name. That's going to be our query right there. Copy. We may need to encode like some F's and W's. So keep that in mind. Oh no, we didn't, because it already worked in this one. So D2 bump. Attack detected. Dang. Maybe it's the equal sign. Let's try that one. That was the only thing different, I think. Equals. And then here, decoder equals 3D. I knew that one too. And pound x3d semicolon. Attack detected. The period. Let's try that one. Do I know this one? No. 2E. Ampersand pound x2e semicolon. Dang. Let's look at what's getting sent here to make sure everything else looks good. Maybe that underscore? What was our... One of them worked. So what's different between this one and the one we just sent? The where. Yeah, I'm saying where. So decoder, let's do W57. Definitely did not know that one. W ampersand pound X57 semicolon, like that. Attack detected. Shoot. Table. Maybe schema? No, because schema here. Let's try public. Dang it, our freaking... Well, we can leverage some repeater here. Proxy. Let's send to repeater. We'll send that. Make sure we get the attack detected. And then let's try P for public 70. Peter. Ampersand pound X. Was it 70? Decoder. It was 70. Peter. Attack detected. What's different between the one that worked and the one that didn't? Oh, you know what? Gosh, you guys are probably screaming at me. Change a word, select all capitals with a capital S so that it gets done there. And we're going to do that. Change a word from, for all of them, for that we need to change a word where, table scheme. Sorry. It worked, sort of. We got no response back, but we didn't get blocked by the WAF. So something's select. I wonder if it's this. Does it have to be? We know it's Postgres. Select table name, table schema equals public. Did I maybe spell something wrong? Select table name from information schema tables where table schema equals public. Oh, you know what we don't have is the comment out stuff at the end. Because that's going to be required for everyone, I'm going to add that here, and that is ampersand pound x2d semicolon twice. Dang it. Let's remove the conditional. Go back. Make sure we have this working. So I'm gonna just copy this line, paste it, comment it out, and DT double quotes. Select table name from information. Why don't we have a union? Again, you're probably screaming at my video. All right, we don't need a space there because it gets handled. Sorry. Dang it. It's disappointing. Boom. All right, well, all that work and the table name is just users. So let's get that from the response, and we'll do it programmatically. So table name equals, we're going to do our regex, so pattern equals re.compile. We want it to start we want it to start, which is the caret with users. Let's start with like that. And since it's only users, I mean, we might as well just end. Or just, I'm having a hard time here because I expected this to have some random value and we don't need it. So I'm trying to make it more complicated. M equals pattern dot search in the resp dot text. Table name equals M1 print table name. Well, comment that out. We're going to need that again, I suspect. Import RE. No such group. So this didn't work. Why didn't that work? Pattern RE compile. What did I do wrong? We can split up for, we can do like lines equals resp dot text dot split lines. How do we get just I don't know why this didn't work. We can do, oh, maybe it has like the carriage return at the end. So oh, because we don't have a capture group. You freaking crazy person. This is the wrong way to do this. If you're looking for good quality Python advice, I failed you at multiple levels on this one. Why am I just, I know the user table. Why am I already compiling it? Whatever. Let's go full freak and put that as a capture group. And then, boom. Then we can use our M1. Now we're all set. So if the table changes names, we just have to update our regex, which, you know, we would have had to change our... Anyway, now we need column names. So we want payload equals format payload union column name from, and let's double check that, Postgres. Pretty sure it's column name. So we can do here, select column name from information schema dot columns where table name equals actor. That works. That's what I want. I do need to capitalize it. If I was using this, I would add in the lowercase also, but I'm not going to for this script. Information schema.columns, or I would just freaking, you know, entity encode every character, XML character encode everything. Column name from where table name equals, here's where we need table name. We need to F it now. And then we need to send the new one. This should get all the columns. Password and username. Oh gosh. I'm going through all this trouble. All right. Well, I'm going to just cut this one short. I'm not going to go through the regex again. I really thought they were going to name the table special to give that extra little challenge, but I guess not. Payload equals format payload. We don't need F. We just need union select password from users where username equals administrator. Like that. We'll send it one last time, and we'll print it, make sure we got it, and then we'll pull that out of the response. There it is. Print response.text, so there's only that. So can't we do like password equals print the password is password I don't know if this will work, but might as well try it. Yeah, that worked fine. So that's what we're going to do. And now we need to log in finally. So shop.login with the administrator and password. And then we can do shop.isSolved. So I made this a lot harder than it needed to be. But I also made it a little bit more versatile. Of course, if you're writing the script for one, exploit, doesn't need to be versatile. Hey, sweetness. Lab is solved. Let's refresh this to get our banner. Boom. There we go. So let's just recap. We created these three things that I think are pretty cool. The lookup table, format query, format payload. And the way this works is that as we define a payload or a query that we want, we send it to this one, and this one will send it up here. This looks through every character and says if that character's in our dictionary here, a key in that dictionary, swap it for the value of that, entry in the dictionary. And doing that, we were able to XML encode certain characters that we thought would cause issues and get us caught by the Web Application Firewall. Once all of those substitutions had been made, we then reformed it into a string, returned it back here. This is where we plugged it into the XML, structure or whatever. We just plugged our results right in there from that encoding. And then we sent that along to get information back. The first thing we got was first thing we queried for was the table names from the information schema.tables. When we got that back, found out it was Postgres, so we were able to tack on the public. And then next, we wanted to find out the column names. So using that table name, we did select column name from information schema columns, where the table name is what we expected. And then using the results from that, we got the password of the administrator user. And then finally, we were able to log in as the administrator. And that was it. We solved it. A lot of stuff I didn't need to do here, but I hope you understood why I was doing it and kind of what my thought was during it. I expected not be able to guess the table name and the column names. Anyway, hope you liked it. Let me know if you have any questions, whether or not you liked it, or if there's any other way I can help. I definitely appreciate it. Otherwise, I'll see you in the next one. Thank you so much. Goodbye.